Welcome back to R for Economics. In this video, we're going to be talking about the statcanR package produced by Terry Warren. Now, this package allows you to extract data directly from StatScan into your R environment. So when you're here and you're in your data and you want to actually look for something and you want to pull back data and it's an entire table and you can pull back the entire table. So let's look for Bank of Canada. Better if I spelled it correctly. Bank of Canada. And we want to look at some daily series. And here we can see that we can get the Bank of Canada money market and interest rates. So this will have the overnight rate. It will have the bank rate and the target rate. And these might be of interest to what you're working on. So to bring this back, you need two things from Statistics Canada. You need this table ID. Okay, so this is the table ID, and you can copy and paste that and bring it over to R. The other thing is the download options. And it's this download MetaCube information. And when you select that one, it'll download your file. And as you look at this file, you'll see that it has information on what the variable is, its classification code, and its geography. Now, this stuff will become more important in a minute. Geography will be the first marker, and then the financial market statistics is the second one. And then it gives an ID of where it lies in here. So if you're looking for number 25, it's going to be the Treasury bill monthly. So this allows you to look at the coordinate system, as it's called, and examine it. Now, if we share R, now in R, we can paste our table ID, and we can now bring in the latest version from GitHub, the version of StatsCan. And we're going to bring in the forecast and the XTS libraries as well. So the first thing we do is we bring in our data set, and this is very simple. We just say statcan data, give it the table, and then say, send it to me in English. And this will take a moment for it to come in. And now we have our data. We can see that the class is called a table, data frame. And you can see which variables it has in it. And you could look at the data if you really wanted to. But it has the reference date, and this is the date of the variable, the geography, some ID, the financial market statistics, so that's the name of it, OUM, scalar factor, it's in units, this would be thousands of dollars or whatever if it's different, and it has this vector. Vector is a unique identifier of the series. So if you're looking for one of the particular series, it'll have, the vector will be unique for that series. Then there's a coordinate system, which is that 1 and 25, will find you that value. And then the value here is the value of the series at that point that you're looking at. So the important things that you want to take note of, at least for this data set, is the reference date, the vector, and then the values. Now, I'm going to convert this into a data frame because it's a little bit easier to use. Class is now a data frame. We can look at the top of it. We can look at a summary of these, and you can see that these, whether they're numbers or character strings. If we want to break up this coordinates into its second digits of financial market statistics, we can use a split string operator, and we can see that we can get splits based on 1 and then the 25, and then we've factored the vector so that we can make sure that we have also the unique identifiers there. This is useful for larger tables where it's more than just 2 entries. When it's just 2 entries, one being the country entirely, then it's not really, the unique identifier is the same. However, for larger ones, there can be up to 6 or 7 of these coordinates that are split. So you get x1 through x6. We can look at this and look for things of particular interest. If we say x2 is 2, oh, well, this should be unique. It's 12 and 13. So it's clearly getting messed up. Okay, so you have to be careful with your data, and you might have to do some additional splitting if you're using the coordinate system at times. And we can see that these are different vectors. So the vector IDs are different for these 2 series. So you just have to be careful when using the coordinates. Next, I'm going to make a function called makeSeriesDay. So here I want to convert all of my data set into a listing of the vectors that make up the data. So I make this makeSeriesDay function, and you can look at that on it when you want to. And then I can just make my vector data by running it. And all I need to enter is my Bank of Canada data that I received. And what this is doing is it's taking the vector information and it's taking the value information and the reference date and putting those together using the XTS, so turning them into time series. Now you can see that my vector data is a listing of XTS. I can do a summary of these, and we can see that there's 39 of these with the vectors, and it tells me how long each of the series are. And it says that they're numeric. If I want to just look at the names, I can get the vector IDs that way. Now let's say I want to plot one of these. Let's say we plot the first one. What we're seeing here is not the series filled in chart. It's finding zeros for the weekends, and it's also got omissions for holidays. So if we exclude zeros and the omitted variables, we can see that we now have a series which is much better related, and you can now make out what's happening to this series along in every year. This one is a different one, where here, rather than taking the V number, $V number, I can take it from the list, the vector data list, and take the 30th one, whichever that is. 27, 28, 29, 30, this one. And then I can see that what my data looks like for that one and the time frame that it's over. Now, does the weekend information, weekend setting to zeros, make any difference? Yes. So it's changing the mean and it's changing the index number of observations. So removing those NAs and zeros is actually important. Now, if we take a series and we coerce it into a TS, which is the forecast option, and we look at a plot, we have the plot that looks the same as we had before, but now time is not is just a sequence. So it is not keeping the date stamp that you can use directly in a plot. So if we remain in the XTS format, we can see that we have the dates remaining. And we could actually go in closer and we'd be able to see that the weekends are just omitted from the plot, the X, the time axis. Now, even if you have things in XTS, you can still actually use the lag operator. So here I've done the lag, and you can see that the 8th, the 7th is now going into the 8th for the lag. This second one is the lag series. So we can see that we're able to do that. And then we can also actually take diffs as well. Now what happens on the Friday with a lag? Well, we can see that here, that it will just take the Monday, the 7th, will take the Friday before, and ignore the fact that the weekend occurred. So lags and diffs all work for estimation. And you may want to look at these and say, oh, well, I want to look at the unique series, or maybe you want to look at the unique vector IDs. And if you want to plot, you can also remember that you can change the main as you go through, and you can also put in different bank rates. Okay, great, and we'll see you in the next video.